In this lesson, we're going to be talking about arithmetic sequences. By the end of this lesson, you should be able to determine the next term in a sequence given the recursive formula. A sequence is any series of number where there is a pattern. We're going to specifically be talking about arithmetic sequences. So in an arithmetic sequence, that pattern that we're going to see is going to have some amount that's going to be added or subtracted. And this amount that is being added or subtracted is known as the common difference. So here we have a couple of again, series of numbers, and we're going to see which ones are sequences, and we're going to look at which ones in particular are arithmetic sequences. So if we're looking at this first one, we see the numbers 3, 6, 5, 4, and 8. And so what we're looking for when we're looking for a sequence is a pattern. So in this case, we're going from 3 to 6, which would be plus 3, and then from 6 to 5, which is minus 1, and then from 5 to 4, which is minus 1, 4 to 8, which is plus 4. So here there's no real pattern. We're not adding by the same amount, we're not subtracting by the same amount. We don't have a repetition of any type. So in this particular case, this would not even be considered a sequence. If we move to the next one, so if we move to the one that's just to the left of it, or to the right, we're looking at from 2 to 4, 4 to 8, 8 to 16, 16 to 32. We can see here that the pattern is times 2. So this is a sequence, but because the amount is not changing through addition or subtraction, this would not be considered an arithmetic sequence. This would be what we would refer to as a geometric sequence. We look at the next one. We're going from 1 to 4, 4 to 9, 9 to 16, 16 to 25. What we see here is that it's the term squared. So this is the first term, so 1 squared is 1. The second term, which is 2, 2 squared is 4. The third term, which is 3, 3 squared is 9. So we do have a pattern here. That pattern is that it's the, whatever term it is, squared. Again, because that pattern is not addition or subtraction, it would not be considered an arithmetic sequence. If we look at the next one, okay, so the one that's just to the right of that one, we can see that we're going from 11 to 12, that's plus 1, plus 1, plus 1, plus 1. And so we do have a pattern here. That pattern is adding and subtracting. And so this one right here, this would be considered an arithmetic sequence, because not only do we have a pattern, that pattern has addition and subtraction. We'll look at the next one. This is minus 2, minus 2, minus 2, minus 2. Again, because our pattern is subtraction, it would be considered an arithmetic sequence. We look at this last one, and again, we can see that there's not really a pattern here. We go from plus 4 to plus 6, plus 10, and then minus 2. Again, no clear pattern here, so this would not even be considered a sequence at this point. Okay, when we talk about arithmetic sequences, there are a couple of different formulas that you can write. One is called the recursive formula, which is what we're going to look at today. And then the other one is called the explicit formula, which we'll look at more in the next video. When you're using the recursive formula, what the recursive formula does is it takes the previous term and it uses that to find the next term. So in the recursive formula, you need the previous term, you need to know the common difference, the pattern that's being added or subtracted, and those two things are what you'll use to get your new term. In our recursive formula, the recursive formula is set up like this. It's this a sub n equals a sub n minus 1 plus d. A sub n, or n, is the term that you're looking for. So it's the term that you're currently looking for. A sub n minus 1 is the previous term, so it's the term that comes directly before the term that you're looking for. And d refers to your common difference. All right. Here we have a couple of examples. We're going to find the next 3 terms in each of these sequences. And then we're going to see if we can identify which ones are arithmetic. And then if it is arithmetic, we're going to identify the common difference. So if we look at this first one, we're looking for our pattern. If we're looking for our pattern, we can see that our pattern is plus 4, plus 4, plus 4. So the next three terms in the sequence would be 4 from that, which would be 32, and then 36, and then 40. You're adding 4 to get to the next term. This would be arithmetic because we have a common pattern of plus 4. So this would mean our common difference, which is D, is positive 4 or plus 4. If we look at the next one, we look at B. We can see that to get from one term to the next, we're subtracting. So this is minus 7, minus 7, minus 7. So to get to the other terms, we would have 46, and then 39, and then 32. Again, we have an arithmetic sequence because that pattern is a constant subtraction, and so our common difference here would be negative 7 or minus 7. If we look at the next one, we have 2 to 4, 4 to 8, 8 to 16. We can see that this one is doubling. So times 2, times 2, times 2. So it's not arithmetic, so we won't have a common difference. But we can get the other term. So times 2 from 16, that's 32, and then 64, and 128. And if we're looking at the last one, we're looking again, we do have a common difference here. This one might be a little bit harder to spot just because we're working with fractions. But if you look closely, you can see, especially from these middle terms, minus 1/4 would get you to 0, minus 1/4 would get you to negative 1/4, and if you tried minus 1/4 here, you get from 1/2 to 1/4. So here, if we continue that pattern, we end up at negative 1/2. Then we end up at negative 3/4, and then negative 1. So these would be our next three terms in the sequence: negative 1/2, negative 3/4, and negative 1. Our common difference here would be negative 1/4. Okay, we want to write the recursive formula for each arithmetic sequence that we see below. And then we want to determine the value of the sixth term. So what you're going to need here from this particular part is your common difference. It's really the only thing you're going to need from this part. So remember, our recursive rule is going to look like this. It's a sub n minus 1 plus the common difference. This being the term that you're looking for, this being the term that comes directly before it, and this being your common difference right here. So if we look for our common difference, we're looking to see from each number, what are we adding or subtracting. So from 1 to 8, we're adding 7 plus 7 plus 7. So for this particular problem, our arithmetic sequence, or our recursive formula, is a sub n equals a sub n minus 1 plus 7. So we're going to replace it with the number that we have, so plus 7. So this right here is our recursive rule. To get the sixth term, we need to first know the fifth term. So if we know, to get the fifth term, we would need to know the fourth term. So if I want a sub 5, then I would need to know a sub 5 minus 1, or a sub 4, plus 7. So we're looking for the fifth term. We don't know the fifth term. We do know the fourth term. What's the fourth term? The fourth term, well, is 22 plus 7. So the fifth term would be 22 plus 7, which would be 29. All right, knowing the fifth term, now we can find the sixth term. So if we want the sixth term, we're doing a sub 6. This is the term that we're looking for. To find the sixth term, we need to know the term that came before it. So we need the a of 6 minus 1, or the fifth term plus the common difference. We now know the fifth term. We know the fifth term is 29. And so to get a sub 6, we need 29 plus 7, which gives us 36. So we know that the sixth term is 36. All right, let's do one more. Let's look at B. So if we're looking at B, we're doing the same thing. Remember, our recursive rule is going to be the same. What we need to find is the common difference first. So if we're looking at this one, okay, our common difference is -2. So when we're writing our recursive rule for this one, it's a sub n equals a sub n minus 1 minus 2. There's our common difference. Again, we're looking for the sixth term, but remember, before we can find the sixth term, we must know the fifth term. So now we need to look for the fifth term, so a sub 5 equals. We need the term that comes before the fifth term. So this would be a of n minus 5, or n of 5 minus 1, or the fourth term, minus 2. Now we know the fourth term. The fourth term is this 6 right here. So a of 5, or a sub 5, is the same thing as 6 minus 2, or 4. Now that we know the fifth term, we can use that to find the sixth term. So to get a of 6, we'll need the a of 6 minus 1, or the fifth term, a of 5, minus 2. Remember, we now know the fifth term. The fifth term is this 4. So to get the sixth term, we would take 4 minus 2, which gives us 2. So our sixth term here is 2. All right, let's look at how do we use each of the recursive formulas to find the first 4 terms. So, in this particular case, you're going to need to pull 2 things. You're going to need to be given the first term. Without the first term, you can't find the first 2 terms. And then you're going to need the common difference. So here's our first term. Remember, here is our common difference. Okay, if we know our first term, we know the common difference, then what we're going to do is we're going to begin to add. So we put our first term, that's the first term. Our common difference here is plus 1. So 1 from 3 is 4, 1 from 4 is 5, and 1 from 5 is 6. And here we have the first 4 terms in our sequence, which are 3, 4, 5, and 6. Now, you may be wondering, okay, why does this equation down here look different than my equation up at the top? They're the same equation. One is written in sequence notation, and this other one is written in function notation, which we've looked at in previous lessons. So let's look at this. Let's look at this one. So again, you need the first term. So the first term here is 0. We need our common difference. Our common difference here is minus 5. Okay, this is our common difference. Starting with our first term. Remember, our first term is 0. Minus 5 from 0 would be negative 5. Minus 5 from that would be negative 10. And minus 5 from negative 10 would be negative 15. So this is how we get the first 4 terms of our sequence, by using the first term and the common difference to get the terms that are coming after that. All right. Is the figure that we see here an arithmetic sequence? Okay, if it's arithmetic, remember that what we will see is a common difference of addition or subtraction. So here we have 3 squares. Here we have 5. And here we have, it looks like we have 7. So do we see a common pattern here? And we do. We see that from 3 to 5, that's plus 2. From 5 to 7, that's plus 2. So yes, we have an arithmetic sequence. Our common difference is that we're adding by 2. So it says, what would diagram 5 look like? Well, if you continue, diagram 4 would have 9, and diagram 5 would have 11. You would just continue that pattern. So it would have 11 squares, and it would look like an L. So we'd have something that looks like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So you'd have something that looks like this right here. All right. And then if we wanted to write the recursive formula, remember that all that you need for the recursive formula is the common difference. So a of n and a sub n minus 1 are going to stay just like that because we don't know what term we're looking for. which means we don't know the term that comes before it. And then the common difference would be our plus 2 here. So this would be our recursive formula. Okay. Before watching the next video, I would like for you to consider what a recursive arithmetic sequence is. I hope you found this video helpful. As usual, please subscribe to the channel so that you get updates on new videos.